All right, and welcome. So this is going to be experiment number 17. This is your lab data video. All right, now your lab data video is going to be a little bit different this time. Right, so you've already done the pre-lab. You should have already done the lab survey where you did some of those practice ones. And so this is going to be the video that's right here in this lab data. Okay? And so how we're getting this data is kind of in two ways. And so one of them is I want to show you the simulator so that way you can kind of see what you would normally would have done. Right? And you can do this on your own computer. The only tricky part is it does mean that you have to run Java in order for this to work. But there's the link down here. This is one of those PhET simulations. And so when you click on it, it brings you over here. And so you would have to download this Java thing. Now I know not everyone has the ability to run it. And so only do this if you feel comfortable doing it. If not, that's okay. I'm going to walk you through what it would look like. So if you ran it, you would get something that kind of looks like this. And so this is a discharge lamp. And so what's kind of happening is we're exciting electrons, and those electrons are going to hit this element here, or our atom, and we're going to try to kind of excite them forward. Right? So we're trying to add in these electrons to kind of make this atom get excited and then maybe discharge something, right? So we're trying to like bounce out electrons, things along those lines. So what you want to do is go over to your multiple electron approach. We'll reset all of this. And yours probably looks something like this. Right? So what I want you to do is go ahead and turn on your spectral photometer. You don't need the squiggles. You can choose to run into slow motion if you want or not. And then what we're going to do is we're going to hit play. So we're going to do a continuous amount. Right now we turn it down a little bit. Right? So right now it's got a lot of different elements inside. And so we want to choose just one of those elements. We're going to choose mercury. So this is for part 1. So all of these are mercury elements in there. And so what we're going to do is we're slowly going to produce some of those electrons so we can start to move it forward. So these electrons you can see are kind of getting excited into here, and the spectral photometer is showing us those colors that we would see down at the bottom. Right? So as we see more of those colored ones, it's picking it up, it's detecting them, and we can see that build here. So if we want to crank this all the way up, we can go at 100. And so we're sending a lot of photons there, or electrons. We're exciting a lot of electrons. We're getting a lot of photons produced as they get absorbed or not. And you can see our 4 spectra that we're going to be interested in. We're not going to worry about this red one down here. We're not concerned with that part. Right? But we're looking at these different spectra as formed by the mercury as it gets excited. And so this is where we get those values for part 1. This is our violet one, our blue line, our green line, and our yellow line. And you can kind of see what our values kind of look like down there. Right? And so that's what part 1 kind of looks like. We're going to take those values, whatever we would have seen. So right now, they've already got it down here in nanometers for us. If we had done this with our own spectral photometer, we would have gotten in centimeters. And so we'd have to make that conversion. Right? Hydrogen, on the other hand, is going to have a completely different look. So when we start to excite hydrogen, we start off on the slow side again. You can see that we don't get the exact same colors or spectra because their energy levels are a little bit different between hydrogen and mercury. So as we increase this one, we can bombard it with a lot of different energies, right? So that way we can really start to see what kind of wavelengths we would produce from its emission. And you can see that we get basically 3 lines down here and the 4th one up high. Right? And so those 3 lines are kind of what we're looking at for part 2. We're looking for that turquoise, that violet, and that purple. So I think in this case, we're saying this one is violet, and then this one is going to be our purple. And then this one all the way up here is our red, right? So those are our 4 lines that we can see for part 2. And so that's what we're doing. That's how we get our discharge lamps. Now, for your experiment, if we had done this in the lab, we would really have something like this, where there's kind of these like beams here, and then this thin area. And that thin area is where we're going to see that discharge lamps. Now, this concept is the same thing that you see out when someone has neon lights, right? If it's got that reddish kind of orangey color in there, that's the neon that's being excited. Different colors have different ones. So you could have a hydrogen lamp, you have a mercury one, but in general, we're using neon, and then most of the other ones that you see that are out are going to be things like argon and xenon, right? We don't use mercury and hydrogen as often because they're kind of toxic gases to work with. And so if they start to leak, then it can become a problem, right? So a lot of times we're using the noble gases for those excitations, sometimes helium lamps, things along those lines. And so that's what's going on with our simulation. Now, you can choose to run that or you don't have to. But what I've done is I've created a spreadsheet for you. So if you click on this link right here, it opens up a Google Sheet. And this is where you're going to get those positions on your spectroscope. So you want to write this down onto your lab data sheet so that way you get credit for taking that data. Right? But these are the positions that you would see. So this is for part 1. This is for our mercury lamp. I can actually add that in. And this one down here is for part 2 with our hydrogen lamp. So these are the data sheets that you would get. And then you can ignore the part 1, question number 2, where it talks about other lines that you might see. We don't have to worry about that. And then down below here, I've given you the literature values. I've also given you the, that you don't have to do question number 2, number 3 are to consider this, right? So you only have to do that first question. Now, you are free to graph on your paper, or you can create a graph using your spreadsheet, either one. Now, the spreadsheet is locked, so you won't be able to use this specific spreadsheet to make your graph. But you can make a spreadsheet. Now, remember that for your graph, you need things like a title. You need your axis titles. You also need your units, right? You should have your scales for both axes. So that means that they have markings down there at the bottom so we can see what values they get. It shouldn't just be 404, 434, 546, right? Because you should have that spread out. So we should have those scales for both of those axes. We should have our data, and we should also have a trend line, right? So we should draw a linear trend line, so our best fit straight line, through our data. That way we can use it in order to predict our known wave or our anticipated wavelengths down here at the bottom, right? So these are the known wavelengths, and this is what they're corresponding with. But you are going to be doing your own calculation from your graph to figure out your wavelength nanometer from calibration. So if you are interested in making your own graph using something like Google Sheets, then you want to go ahead and create your copy of this. So you can copy and paste this into a new sheet, right? And then you want to insert a chart. Now, our chart that we're going to insert, we're going to use something called a scatter plot. Now, a scatter plot is just data, right? It's not going to give it any type of value or anything like that. We're going to end up putting those in. And so we're going to use for our x-axis, we're going to use our position in centimeters. And our y-axis, we're going to use the known wavelength. Now, we would want to add in things like your titles, right? So you want to add in your axis titles here inside of your units. You want to add in things like your title for your chart. Right? So we can add in a chart title. This is going to be our mercury spectrum calibration spectroscope. First wavelength. We could also do a horizontal one. So this could be our spectroscope reading in centimeters, right? We want to have our unit there. We could do our vertical one. This could be our wavelength in nanometers, right? So we have all of that in there. Now, the other thing that we want to do is we want to add in a trend line. And so if we click on our data, we can click down here and it asks trend line. So yeah, we want a trend line. Linear is fine. Our color is fine. We can show the R squared. That's telling us how close it is to 1. 1 would mean that it's 100% linear. And so ours is fairly close with that. And then one way that we can kind of get around to finding out what our trend line is instead of using this custom one, we're going to go ahead and use this equation. And so this is going to be our equation for our trend line. And so this is what we can use for part 2 as we work through it to find out our other percentages, or sorry, our other wavelengths for the atom of hydrogen. So now we could take this 6.6 value, we plug it into this equation for the X, and we can find out what its value should have been. And so that's how you can go through it and make your own chart. Once you have that, then watch through the pre-lab video. It walks you through how you can do some of your conversions. So you want to make sure that you understand how to convert your wavelengths into energy. And then specifically, it's looking for kilojoules per mole. So you have to use Avogadro's number. You have to do that conversion to kilojoules. From there, it asks you then to line it up with what energy level. And so just make sure that you understand when you go from a high energy to a low energy, that's when you emit a photon. And so that's what we're doing in this experiment, is we're going from high energy levels to lower ones, because these are all emitted photons. These are not the absorbed ones. And that's all you need to do. Once you're done with this, you upload it to Gradescope like usual. Good luck.